All right, welcome back to the channel. In this video, we're going to be talking about multiplying radicals. Before we get into some actual examples, let's look at a general pattern that we're going to use with our examples. And these are two radicals because they both have radical symbols in them. If I asked you, if I put $1 million on the question, how would you multiply those numbers together? I bet you would guess, and you would guess correctly. And if you said, well, the A and the C, they look like they're outside the radical, so they feel like they could be times together. And then the B and the D, they're inside radicals, so it feels like they should be multiplied together, you would be correct. So to multiply this, it's pretty simple actually. It's the A times the C, so A times C, okay? And then for the radical part, I'm going to multiply the B times the D. So it's going to be the square root of B times D. And the only other thing that we really have to notice here is that sometimes the radicals aren't square roots. So if I make both of those indices n, saying that they have to be the same, 2 for square root, 3 for cube root, 4 for fourth root, and so on, then I'm paying close attention to that to make sure that those numbers are the same. So if the indices are the same, then you multiply the numbers under the radicals and you have to report the index value in your answer. One other point to be made here is that if n is even, okay, now your teacher's going to add this to your workload. If n is even, and let's take the smallest case where n is 2, then that would be a case where you're taking the square root of a number. And you can't take the square root of a negative number in the real numbers, okay? So if n is even, then that requires that the numbers b and d can't be negative. So in other words, b must be greater than or equal to 0, as well as d must be greater than or equal to 0. And I've made videos on radical restrictions, so look those up if you need extra help with your radical restrictions. All right, for our first example, we're simply going to multiply the numbers outside the radical, or the front numbers, or the coefficients, whatever you want to refer to it as. And so that's -3 times 4. Do you see? Those numbers are multiplied just like you did when you were in grade 4. Now, I've got the radical part, so those are going to be multiplied together. So under a radical, you put them both under a radical, you multiply them together. Now, I'm showing all my steps because you're here to see the gory details, but you might simplify this. You might cut out some steps, okay? And then you combine. So -3 times 4, well, that's just -12. And then under the radical, I've got 2 times 6. Now, if I multiply those together, I get 12x, which is fine, but notice that 12 can be simplified because 12 holds in it 4 times 3, and 4 is a perfect square. So you always want to double check to see if the radicand, or the number under the radical, if you can pull more number out, like mining for number, and you can here. So this is going to be equal to -12 square root 4 times 3 times x, do you see? And now the 4 is a perfect square. So I now can write my final answer. I'm going to just cut it there. I know what the square root of 4 is, right? It's 2. So -12 times 2. Now the 3x is stuck inside the radical jail because it's not a perfect square. So I have to keep it inside the radical. So final answer, -12 times 2 is -24, and the square root of 3x is the square root of 3x. And there's your final answer. All right, so let's take a look at another example. This one's a little different because now I have a monomial, a single term, multiplied by a binomial, 2 terms. So we use the same ideas as we did with polynomials. So you're going to expand or distribute. So here I'm going to multiply this by this. So I'm going to right away get my strategy. The outside number 7 and the outside number 5 are going to multiply together. I'm going to show all my steps because it might help you, but you can definitely just write the number 35 here. And then the square root 3 times the square root 5 is the square root of 3 times 5. Then I'm going to take the monomial again and multiply it by this. So all the way across. the sign is minus, so a positive times a negative is a negative. 7 times 6, so 7 times 6. And then under the square root, under the radical, 3 times 3. 3 times 3. And then the rest is really just some basic arithmetic. So 7 times 5 is 35. Everything is times land here. 3 times 5 is 15. And then 7 times 6 is 42. And then 3 times 3 is 9. This is an interesting one. The square root of 9 is 3. So it's nice to get into the habit, if you have something like the square root of 3 times the square root of 3, you can just simply answer it as 3. So another example would be the square root of x times the square root of x. Well, the answer is simply x. And then finish this here. So we'll multiply the 42 by the 3. And there is your final answer. Notice that the first term has a radical, the other one doesn't. That's okay. These answers can look in all kinds of forms. All right, so here's another example. This is now a binomial times a binomial. And you might remember in earlier grades, we used this thing called FOIL. So first, outside, inside, last. FOIL, first, outside, inside, last, which helps you remember all of the combinations that you have to take into account for multiplying. Okay, so here we go. One thing I'm going to notice is the 5 doesn't have a radical, or does it? Well, every number kind of does, right? So the number 5 is 5 square root 1. I'll use that. So here equals. So first, I'm going to multiply the firsts together. So 8 times 9, I'm just going to say is 72. And then the square root of 2 times 5 is the square root of 10. Okay? And then the outside, so 8 times 6 is positive 48. And 2 times 10 is 20. So the square root of 20. Now the inside part, so a negative times a positive is a negative. So that's going to be a 5 times 9, which is 45. And then a 1 times 5, which is 5, root 5. And then last but not least, the 5 root 1 times the 6 root 10, don't forget the minus, is going to be minus 5 times 6 is 30. And then 1 times 10 is 10, root 10. Now when I look at that, I notice that this has a 10 and this has a 10, so they can be combined. So I'm going to combine these together first. So 72 minus 30 is 42. So 42 root 10. So those two simplify down to the single term. We always want to do that. Always go to simplify. And then this one is positive 48. And of course, square root of 20 is square root of 4 times 5. And then now you can see that it has that 5 common. So that allows them to be considered like radicals. Minus 45 root 5. And you can sort of, after a while, you get good at this. You know that the root 4 is going to be a 2, okay? And that the 5 is going to get stuck inside. So you can start abbreviating some of your work. It's going to make it go a little bit faster, and you'll probably enjoy it a lot more. So 42 root 10, nothing there. 48 times 2 is, I believe that's 96. 96 root 5. And then minus 45 root 5. And now again, these are like radicals, so I can combine them to a 42 root 10 and 96 minus 45. That one isn't too bad. It's going to be positive 51 root 5. And I'm going to put a big box around my final answer. All right, final example of the video. So this one involves a monomial and a binomial like we saw earlier. The difference here is that I've got cube roots. And so for cube roots, I want to know my perfect cubes. So 1 cubed, 2 cubed, 3 cubed. Hey, let's go up to 5 cubed. I usually recommend to students know the first 5 at least. For your perfect squares, know at least the first 12. And so 1 cubed is 1, 2 cubed is 8, 27. 4 to the 3 is 64, and 5 to the 3 is 125. So we're going to expand that first term through to the others. This is equals. There is a coefficient. If it's not indicated, it's 1 on the radical. So 9 times 1 is 9, and this is a cube root 4w times 2w. So 2w, I'll show all my steps here in case that is important for you. And then this times that is a positive. 9 times 7 is 63. And then I'm going to multiply those together since they're both cube roots. So 2w times 28, I'm just going to say 56w. Okay? And so now I have to be mindful to pull any number I can out of the radical. I always want to go as simple as possible. And the general movement there is from inside to outside, okay? So let's play with that. So here I want cube roots. So 2 times 4 is 8. That's good news, because in cube root land, 8 is a perfect cube. So you can see the cube root of 8 is 2. And the w times w is w squared. That's not a cube, so it's going to get stuck inside there. Let's take a look here. So plus 63 cube root. Now 56, 56, you always want to think what numbers break that down. So I know that 2 times 28 is 56, and then 2 times 14 is 28, and then 2 times 7 is going to give me the total 14. And then w. Okay, so look what I've done. I've broken this down. You could have also said, what's the biggest perfect cube that goes into 56? And it's 8. 7 times 8 is 56. So here, well, 9 cube root of, I'll show an extra step, 2 cubed w squared. And then here, plus 63 cube root 2 cubed times 7w. So whenever you have a cube root acting on a cube, they annihilate each other. And you're just left with the number that is being cubed inside. Do you see? Just like that. So here, if I simplify this now, that's going to be equal to, well, the cube root of 2 cubed is 2. And 2 times 9 is 18. The w squared is stuck inside, so that's cube root w squared. That's kind of interesting because we have an index 3 and we have an exponent inside. Now here, the cube root of 2 to the 3 is 2. So plus, that means I'm going to pull the 2 out and double this. This is going to be multiplied by 2. And that's going to be 126. Now the 7 and the w, there's nothing I can do with those. They're not in triples. So they get stuck inside the cube root jail. And then I check to see if anything is like, and these are not like, I can't combine them, and so this ends up forming the final answer. So I'll put a box around it, and you can see the answer looks unusual, and you've got all kinds of stuff going on. And as you do more of these and you practice, and you really have to practice, you'll get more comfortable with answers looking unusual like this, okay? All right, if that helps, slap a like on this video, subscribe. I intend to really build this channel up with lots of videos. There's tons of videos already on radicals, so check those out. And until next time, take care.